Hey everyone, welcome to your play pause it for the day. We are going to be going over the notes from our class last week from November 3rd. So you want to go ahead and have those available and your OMHS play pause it graded assignment. Let's get started. So today we're going to basically just do a few examples of analyzing functions. And this is going to help us a lot with that 4.04 extension assignment. This is one that you guys are going to have to do where you write out your work and then you're going to submit it via the Dropbox feature. So if you need any help at all with that, please don't hesitate to reach out. So this is from last class. Our first question over here on the right for this graph, this is showing John's savings account balance for the year. So you can see along the x-axis, we have the months from 0 to 12 for one whole year. And then on the y-axis, we have how much money is in his account. So is this a function? And yes, it is, right? We could try our vertical line test where if we were to take a vertical line and drop it down any place on this graph, it would only hit it one time, right? So yes, this is a function. What is the domain? Remember, the domain are the x values. So what we're going to do is we're going to pretend we're taking a walk along the x-axis. And what x value do we get to first? Well, if I take a walk, this guy is going to hit the graph right here. And the x value is 0. So our first x value is 0. And then we're going to keep walking along the x-axis until we get to the end of the graph. Oh, here's the last point on the graph. And the x value there is 12. So our x values go from the interval on 0 to 12. So remember, we need to decide if it's going to be a parentheses or a bracket. You guys remember when we did number lines? And if it was something like less than 2, then it was a filled in circle, right? And if it was something like less than or equal to 2, then we knew it was going to be a filled in circle. So we have the open circle versus the filled in circle. The filled in circle meant that it was included, right? It was allowed to be that value. Well, this means the same thing. This function has 2 filled in dots on the ends, so that means it is allowed to equal those values. So when we're doing interval notation, an open circle is parentheses and a closed circle is brackets. So the parentheses will indicate that the value is not included, and the bracket will indicate that it is included. So we're going to use brackets here because that is a single filled in dot. So it is allowed to equal that value right there. If this line kept going and it was an open circle, then we would have a parentheses. Okay, what is the range? The range is the y value, the y values. So this time you're walking along the y-axis, and we're going to start from the negatives to the positives. So we're going to see where do we hit that line first as we're going up. And it happens right here at 300. So the range will go from $300 until what? Until the function stops, and it stops right here at 1500. So those are the range of values that the y is allowed to be. And again, these are both going to be brackets because it is filled in at both of those places. I'm going to grab another color here. The next question wants us to find f of 3. Remember, we read this function notation as f of something. And this little value in here is the x value. So this is saying if x is 3, what is y? So we're putting 3 into the function. X is the input. So all we're going to do is we're going to go on the x-axis at 3 and see, well, what is y? Where does the function exist? Right here. So we go up to the line and then over and see that the y value is 600. So f of 3 is 600. How about f of 10? We're going to go on the x-axis at 10, go up to the line, go over and see that y is 1300. So when x is 10, Y is 1300. Remember, another word for Y is f of x. They're like synonyms, right? So f of 10, they're saying, what is Y when x is 10? Now this last one is sort of reversed, right? We don't know the input. We don't know x. But we do know the output. We know f of x. We know y. So when y is 900, find x. So it's kind of reversed. So we'll go to 900 on the y-axis, follow the graph, and the x value is 6. So we're just using those values to sort of analyze the graph and see. If you wanted to put some context to these numbers, we could say, f of 3, that means after 3 months, how much money do I have? And it's projected he'll have $600. Or maybe it's like, oh, how long is it going to take me to reach $900? I want to buy this really cool game system and I need $900. How long will it take? Oh, it's going to take me about 6 months. So you can see how graphs can be super helpful, especially when planning for the future. So this is what we're going to do in our breakout rooms. We'll do it together here. It says, state the relation, then find the domain and range. So remember, we can represent relations and functions different ways. We can do it on a coordinate plane. We can do it in an XY table. We can also do it as a set of points. Let's do that here, where we just list out the points. So this is -3, 2. And I'm just grabbing them as I see them. -1, -5. And then 1, 6, this guy, 4, 2, and the last one is 5, 0. And remember, we use these curly brackets to show a list of numbers. And then we can put those into our table here. So these are all different ways that you can represent a function or a relation. Now let's do the domain. Remember, the domain are the x values. And here we have distinct values, right? They're just points. In the last example we did, we had a line. So we had sort of a range of values. They were all connected. Here, they're distinct values. So we just list out the x values. That's it. I just grabbed the x values from those coordinate points. And typically, you're going to see them written in numerical order from least to greatest. Right, the range are the y values, so we're going to do the same thing. And I'm just going to match them up in this case. 2, 0. There we go. And lastly, they want to know, what is f of 4? So remember, 4 is the input. It's inside those parentheses. So this is really asking, when x is 4, what is y? So x is 4, y is 2. Let's try another one. Don't forget, you can pause this recording at any time. If we look at this graph, we can already see it's different from the last example because, again, there is a line, so they're connected. But also check it out. Those arrows on each end of that line means it extends and goes on forever. So we had that example where it had the dots on the ends. So that was showing the beginning and the end. Here, it goes on forever in both directions. So it's going to change the way that we write some things. So is this a function? Yes, it is. It passes that vertical line test. What are the x values? What is the domain? So we're going to take a walk along that x-axis from left to right, like we read a book. And where does my person hit the graph first? So you might think right here at this value. That's the first part of the graph I see from the left. And you're absolutely right. But how do you write that? That's an arrow. It's going on forever. We can't just say -2 because x can also be -3, -4, -5, -6, right? That arrow indicates it goes on forever towards the left. So what number is forever towards the left? We think of a number line, zeros in the middle. You have your positive numbers towards the right and your negative numbers towards the left. So if we want to say what number is all the way to the left forever and ever and ever, that is -infinity. Some people write infinity like this. I do. And then others will do like the sideways 8. And I'm sure right now you guys, a lot of you can do it on your keyboard. And I hope that you teach me how to do that next class. I always forget. I always write it like a halfway snowman, sideways snowman. All right, so then it's an interval, remember? So we're going to have a comma here. So it starts at negative infinity. And where does it stop? If we keep walking along the x-axis, the arrow on this function goes up, 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 up to the right forever and ever and ever and ever. So what value is to the right forever and ever? That is positive infinity. So now we just need to decide if we're going to have parentheses or brackets. And I'm here to tell you, you can never have a bracket on infinity. You can never have a bracket on infinity because remember the brackets indicate that it is allowed to equal that number. Can you ever equal infinity? No, because infinity is not a distinct number, right? It's not a million, a billion, a gajillion, a trillion. It's not a distinct number. It's just a representation that the number is going to keep going. It's never going to stop. So we can never say that something is actually equal to infinity because infinity itself is not a distinct number. There we go. So we're always going to have parentheses on infinities. When you look at this, this kind of looks like a coordinate point, right? An x value and a y value. So just be careful when we're talking about the domain. The way that we write this represents a range of values. It starts at negative infinity, it stops at positive infinity. All right, let's talk about the range. The range are the range of values for the y values. So if we look at the y-axis and go up, where does the function start? It starts right here. And that is a distinct value, right? There's just a dot on that vertex of that v, and it is 0. And it's allowed to equal that 0. There's no open circle there, so we have a bracket. And then where does the graph stop on the y-axis? If you keep going up along the y-axis, where are you never going to find the function living? Well, it's always going to be up here, right? Because these are going to just keep going. So we're going to go to positive infinity on the y-axis. All right, let's do our f ofs. So 2 is the input, so we're going to go to where x is 2, and what is y? So when x is 2, y is 4. How about negative 1? When x is negative 1, here, what is y? It is a positive 2. So we're just sort of reading our graph, analyzing it. Now the last one, remember that's in reverse. It wants to know what is y. I'm sorry, it wants to know what is x. What is the input when y is 2? F of x is 2. So we're going to go on the y-axis at 2. And we say, well, what's the x value? Where does the function live? Oh, it lives right here in 2 places. When y is 2, x lives in 2 places. So we could say x equals negative 1 and x equals positive 1. We have those 2 values. If you were to take the coordinate point, you would get 2 different coordinate points with the same y value. So negative 1, 2, and positive 1, 2. Remember, it's okay to have the same y value. It's not okay to have the same x value. Right? If the x values were repeating, then we would not have a function. That would mean it would be something like this, like sideways, right? Because if we had a 4, that would mean the 4 would exist at this point and this point. So that x value would repeat. All right, let's do some more. So I wanted to pull up your extended assignment. I think this is on your, it was originally on your plan for Tuesday. And I do apologize for that. I'm honestly not sure how that stayed on there. I would have like, I don't know, I would have bet $1 million that I moved it because I knew that you guys had benchmark testing on Monday and Tuesday. So I swore that I moved it to Thursday, but I didn't, or something happened. But I'm glad I realized that pretty quickly, and I moved it to Thursday. So for those of you who already started working on it on Tuesday, that's okay. And I wanted to go over a little bit so you would have some sort of a frame of reference, a little bit of help to get you started. So here's a graph, and a lot of people were emailing me, not a lot, a few, saying there's no numbers on this graph, and I totally understand that. And it can be a little bit confusing. So we're going to use the clues that they give us in the problem to essentially put numbers on the graph to give it meaning. This is a graph representing a bank account, Ebony's bank account, B of D. So that's just kind of another way to say f of x. It's a function on the number of days, D. So D along the bottom, that input, right? The x value, the input, is along the x-axis. And B is along the y-axis, the balance. The graph shows segments representing her day-by-day bank account balance. Although there are no labeled tick marks on the graph, you can answer the questions by using the additional given information as well as your general knowledge of graphs and functions. So the first thing they tell us is that Ebony kept her bank account open for 3 weeks. That's our very first clue. We know how many days are in 3 weeks. There's 21 days in 3 weeks. So this graph goes all the way to from 0 days to 3 weeks to 21 days. So we are able to now mark this point here at the end as 21 because the x-axis is the number of days. The graph shows the entire 3 weeks. That's how we know the end of this graph is 21 days. Also, it says during that time, her greatest balance was $400. So the largest B value, or sort of the Y value, is 400. It's going to be about here. That's the highest point of that graph, is $400. So we've already got 2 really good clues, 2 really good pieces of information just from that first sentence. Let's go to the first question. So here I'm going to label this again, 21 and $400. So A says give the domain and range of the functions. Remember, the domain are the x values. So where does the function start along the x-axis? Remember, the domain are the days. So if you think about it, when you open a bank account, you're going to open it and essentially there's kind of 2 ways you can think about this, right? It's 0 day, like you go in at the very beginning of the first day. So it'd be like from, 9 a.m. until 9 a.m. the second day would give you that first day. So some people insist this would start at 0 days and sort of tick over, 0 to 1, 1 to 2. I understand some people can make an argument for this being a 1. So I would take sort of both arguments, like the first day I had this much money. I'm going to start it at 0 days, because I'm thinking of that sort of that tick over. Like 0 time. When I first opened that account, no time has passed. I'm just there. I'm in the office. Clock is starting at 0. I give the guy a certain amount of money, or girl, and it's 0. All right, and then where does it stop? We know that our domain is the number of days, and the greatest it can be is 21. Both of those are going to be brackets because we have some filled in circles at both places. All right, and then the range are the y values. So we're going to start on the y-axis, and you can see there's actually no negative y values, which makes sense in the beginning anyways, that you would not have a negative balance. So it would start at 0 on the y-axis and stop at 400. They told us that that was the greatest amount that could be in the account, domain and range. B says, give an estimate to the nearest hundreds for B of 0. So this first word here, estimate. So you guys might have all a variety of different answers, but they should all be about the same for B of 0. So what does 0 represent? 0 is the number of days, right? D. So at 0 days, they want to know, what is the balance? Explain how you determine your estimate and tell what B of 0 means in the context of the situation. So 0 days have passed. You're going in to open your bank account. how much money do you give the teller? Well, at 0 days, we have about this much money. And there's no value there, right? We don't really know, but we could estimate because we know how much total we have. This looks about half to me, honestly, maybe a little more than half going up, but I would take the answer of 200 here. It's about half, maybe a little more than half, maybe 220. I'm going to say 200. So B of 0 is $200. So on day 0, right? You're going in, you're opening your account, you have to give the teller $200 to open it, just to begin, just to start. So the context of that situation, you want to use words that relate to the actual Y value. So I'm not going to write it all out, but you would say something like, when Ebony started and opened her account, she had $200 at the beginning. That's really the context of the situation. This 0 days means the beginning, and B of 0 means how much money she had. All right, C says Ebony's bank account first reached $0 on day 12. So she first opened the account, she had $200, and then some days passed, and you can see her bank account increased. And some more days passed, and it kind of leveled out. Some more days passed, and she started spending, and the money in the bank account is going down, 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 down to 0. And it tells us this happened on day 12. So now we have another clue. We get to label another x value on the x-axis. It first became a balance of 0 on day 12. How would you show that information in function notation? So remember, function notation is this f of x business, or in this example, it's b of d. So they want us to take these values, 0 and 12, and put them into function notation. So what does 0 represent? $0 represents the entire b of d, right? And d is the number of days. So we would say b of 12 equals $0. I would probably just write b of 12 equals 0, leave off that $sign, but either way, I would not count you wrong on that. But the input is the x value, or the little d value here, the 12. So that's going to have to go on the inside of the parentheses. And the output is the amount of money, $0. Lastly, Ebony's bank account remained $0 from day 12 all the way through day 15. Ooh, look, we get another value, another clue. This is day 15. So from 12 to 15, she had $0, right? 0 along the y-axis. As you count segments from the left, which segment on the graph represents this information? Explain how you know. So if we label these segments, segment 1, segment 2, segment 3, 4, 5, 6, right? There are 6 segments. And we kind of already, I labeled it essentially. You guys can see this is the segment that goes from 12 to 15. Segment 4, so it's segment 4. And how do we know? Well, we know that that's the right segment because that's where the bank account equals 0. That segment is when y equals 0. So that's what you would say. You could say along the segment days 12 to 15, the bank account equals 0, which is what they told us. So sometimes this explain how you know stuff, I don't want you guys to get too bogged down in that. As long as you sort of give an explanation on how you got the answer, that's fine. It doesn't have to be anything super complicated, super mathy, if you will. Just how did you know? How did you know? And it could be, well, I read the graph. Don't just say I read the graph, but I read the graph, and on segment 4, the y value is 0. Okay, I hope this helped a little bit for you to continue working on this assignment. And I know that the first due date for this is tomorrow, Friday, the 13th. But you guys don't forget, that you don't have to turn it in that day. Yes, come Monday, there'll be a 0 there if you didn't turn it in. But we have until our next end date, which I think is January 22nd, I think. where you can no longer do it again. So because of our sort of strange week, if you still need help on this, please feel free to come to an extra session next week with Miss Jadala. Reach out to me, come to office hours, and we can get you some more help on this. I have missed you this week. I hope you guys have been having a good week. I know a ton of you completed that USA test prep benchmark assessment for me already. If you have not yet completed your Algebra 1 play or Algebra 1 benchmark, please log in and do that as soon as you're able to, as soon as possible. Coming up next Monday, we are going to have our play posit as usual, and then we'll have class on Tuesday, and some of us have class on Tuesday and Thursday. So we'll get to see you guys next week. All is as usual next week. And then the following week is our fall break. So Monday and Tuesday are teacher work days. So we won't have live classes, but you guys will have assignments and we'll be available if you need us. And then starting Wednesday is your official fall break. All right, you guys, just reach out if you have any questions at all, and I'll see you next week. Bye.